Hi guys, and welcome to this tutorial where I'll be introducing the concept of inverse proportion, and we'll be looking at several problems using formulas. So what is inverse proportion? Well, two quantities are said to be inversely proportional if, as one quantity increases, another quantity decreases at a constant rate, or as one quantity decreases, another quantity increases at a constant rate. An example of two quantities in the real world that can be inversely proportional are speed and time. We can use these table of values to illustrate the different speeds and times that it takes for an aeroplane to travel part of a runway which goes from the fixed point A to the fixed point B, where the distance between these points is 50 meters. Now this table shows the inverse proportional relationship between speed and time when the distance is fixed. Looking at these values, the easiest thing we can notice is that as the speed increases, the time taken to travel from A to B decreases. But how does this happen? How exactly does one quantity change relative to the other? Well, this is exactly what proportion is concerned with. So let's look at what's happening with the change in particular values. Starting with these values, when the speed changes from 5 to 10 meters per second, it doubles, or in other words, we multiply by 2. But what happens to the change in time? Well, the time changes from 10 to 5, so it halves. Or in other words, we divide by 2. And we can see that this same relationship holds between any two values of time when the speed doubles. For example, 10 to 20. We see that the time halves from 5 to 2.5 seconds. We can see the same pattern when we change the speed by a different factor. Let's look at the change between speeds of 5 meters per second to 20 meters per second. Well, this speed is 4 times greater than this speed, and so the equivalent change in time would be 4 times smaller. In other words, we divide by 4. We also see the same change between the speeds of 10 to 40 meters per second, which is also 4 times greater. We see that the equivalent time is 4 times smaller. If you do 5 divided by 4, you get 1.25. Okay, so it's this type of relationship and behavior that's typical between two variables that are inversely proportional to each other. Now, there is one more important observation that we can make from this table of values. Now notice what happens when you multiply each corresponding speed with its time. You get the value of 50 in each case. The same value as the fixed distance traveled by the plane. Now, as we're looking at using formulas to represent inversely proportional variables, given this observation, what general formula do you think we can use to describe the relationship between speed and time? I'll give you 15 seconds to try and work this out. Were you able to get it? Okay, now if we let S be the letter representing the variable speed and T be equal to the time, well, given the fact that each value of S multiplied by its corresponding value of T gives us 50, we can form the equation that S times by T is equal to 50. And if we were asked to write an expression of S in terms of T, well then by dividing both sides by T, we would get that S is equal to 50 divided by T, giving us a general formula for S in terms of T. Okay? Now looking at this formula, some of you will have recognized that this is the formula which relates the variables speed, distance and time, where speed is equal to distance divided by time, where in this case, distance is a fixed constant. Now if we're told that S is inversely proportional to T, this is an equivalent statement to saying that S is directly proportional to 1 over T. So using the notation that we used for direct proportion in a previous tutorial, we can therefore write S fish sign 1 over T, and therefore S is equal to K times by 1 over T, where K is our constant of proportionality. Or we can write this as S is equal to K over T. In this example, our constant of proportionality K was 50. Now this is the way that we would use equations and formulas to represent inversely proportional variables. And it's an interesting point to mention that using fractions where we have a constant value in the numerator and a variable in the denominator is the only way we can represent this definition of inverse proportion without using a negative sign. That as one quantity increases, the other quantity decreases. And you can see here that as the value of t increases, this fraction will get smaller, causing s to decrease. And as the value of t decreases, this fraction would get larger, causing s to increase. By looking at this definition alone, you may be tempted to use negative signs to show this relationship, but you have to remember that in practical terms, the idea of proportionality is used for positive quantities such as speed, distance, weight, volume, and area. So in a sense, there are no negatives in the real world. And so it doesn't make sense to use equations like this to represent inversely proportional variables. Okay, so let's use our understanding of inverse proportion to tackle some problems using formulas. So the first question says that if y is inversely proportional to x and y is equal to 3 when x is equal to 10, part A asks us to find the formula for y in terms of x. Okay, so since we're told that y is inversely proportional to x, we can write y fish 1 over x, as we saw in the previous slide. And therefore, y is equal to k divided by x, where k is our constant of proportionality to be found. And we can call this equation equation 1. Given the fact that y is equal to 3 when x is equal to 10, we can sub these values into equation 1 as follows to get that 3 is equal to k over 10. And multiplying both sides of the equation by 10, we get that k, our constant, is equal to 30. So in order to write a formula for y in terms of x, we simply sub this value of k back into equation 1 to get that y is equal to 30 over x. Okay? The next part asks us to find the value of y when x is equal to 5. So to do this, we simply need to sub the value of x equal to 5 into our general formula to find the value of y, giving us that y is equal to 30 divided by 5, which is equal to 6, and therefore y is equal to 6. Part C asks us to find the value of x when y is equal to 15. Well, in order to do this, we simply need to substitute y is equal to 15 into this formula, which gives us 15 is equal to 30 divided by x. To make x the subject of this equation, we can start by multiplying both sides by x to get 15x is equal to 30. And to find the value of x, we divide both sides of the equation by 15 to get that x is equal to 2. Okay, let's have a look at the next question. Here we're told that the table shows a set of values x and y. Y is inversely proportional to the square of x. And we've been asked to find an equation for y in terms of x. So given the fact that we're told that y is inversely proportional to the square of x, we can write the following: y fish sign 1 over x squared. And therefore, we can say that y is equal to k divided by x squared, where k is a constant to be found. Let's label this equation 1. Now, given the fact that we know that y is inversely proportional to x squared, we can find the constant k by using any pair of corresponding values x and y in this table. So I'm just going to choose the one that looks easiest to work with, and that's 1 and 9. So subbing x equal to 1 and y equal to 9 into equation 1, we get that 9 is equal to k divided by 1 squared, and therefore k is equal to 9. We can find an equation for y in terms of x by simply subbing this value of k back into equation 1 to get that y is equal to 9 over x squared. Okay. As I mentioned, you could have used any other corresponding pair of x, y values, and you would have got exactly the same result. So do try it out in your own time. Let's have a look at the next problem. So this question is a question with 4 parts, and we're told that the force F newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance d centimeters. When d is equal to 2 centimeters, F is equal to 50 newtons. Part A asks us to express F in terms of d. Part B asks us to find the force when the distance between the magnet and the metal object is 10 centimeters. Part C asks us to find the distance between the magnet and the metal object when the force is 8 newtons. And the last part asks us to explain what happens to F when D is halved. So I'm going to leave you with a few moments to pause the video to have a go at this question. Try to take your time with the question, and when you come back, I'll show you the work solution. Okay, so we've been given information about the relationship between 2 variables, F, the force measured in newtons, and D, the distance measured in centimeters. And we're told that F is inversely proportional to the square of D. And therefore we can write F fish 1 over D squared. Therefore, F is equal to K over D squared, where K is a constant to be found, and we can call this equation 1. So using this snapshot of values, we can substitute D equal to 2 and F equal to 50 into equation 1, giving us that 50 is equal to K divided by 2 squared. 2 squared is 4, and if we multiply both sides of the equation by 4, we get that K is equal to 200. So by subbing this back into equation 1, we can express F in terms of D as F is equal to 200 divided by D squared. Okay. The next part asks us to find the force when the distance between the magnet and the metal object is 10 centimeters. So although this question seems a bit wordy, all it's asking for is us to find the value of F when D is equal to 10. So subbing D is equal to 10 into the formula for F in terms of D, we get that F is equal to 200 divided by 10 squared. 10 squared is 100, and 200 divided by 100 is equal to 2, and therefore F is equal to 2 newtons. Part C asks us to find the distance between the magnet and the metal object when the force is 8 newtons. Again, although a bit wordy, all we're being asked is to find the value of D when F is equal to 8. So subbing F equal to 8 into this formula, we get that 8 is equal to 200 divided by D squared. In order to find D squared, we can start by multiplying both sides of the equation by D squared to get that 8D squared is equal to 200. Dividing both sides by 8, we get that D squared is equal to 200 over 8, and therefore D squared is equal to 25. To find D, we take the square root of both sides to get that D is equal to 5 centimeters. Now in general, the square root of 25 is plus or minus 5, but as mentioned earlier, we're only looking at positive quantities when we talk about proportion. So we take the positive value of 5, okay? The next question is an interesting one. It asks us to explain what happens to F when D is halved. Now I'm going to show you 2 methods of approaching this problem. The first one is going to be using numerical methods, which simply means using numbers. And what we're going to do is we're going to choose any value of D. We're then going to find out its corresponding value of F using this formula, and then work out what happens to F when we choose half of that value of D. So let's use an easy number and let's allow D to be equal to 10 centimeters. Well, subbing this into our formula F, we already calculated the value of F when D is equal to 10 from before. We got that F was equal to 2 newtons, as we have here. Now let's choose D to be half of the value So if we now let d equal to be 5 centimeters, subbing this value of d into the formula, we get that f is equal to 200 divided by 5 squared, and therefore F is equal to 200 divided by 25, and 200 divided by 25 is equal to 8 newtons. So what happened to the value of F when we halved the value of D? Well, we started with 2 newtons and ended with 8 newtons. So the value became 4 times larger, and therefore we can say that when D is halved, F becomes 4 times larger. Now the reason why we're able to generalize this is because since the relationship between F and D were defined as inversely proportional, this relationship would be consistent for any change of values where D is halved. Very similar to what we saw in the first example with speeds and times. We could have also shown this relationship using algebra, which is often the safest way of showing or proving extremely general relationships between variables, such as one we've seen here. So using algebraic methods, instead of choosing a value for D in this formula, well, we can just say that D is equal to D. And then what we need to do is see what happens to this expression when we look at half of D, which is D over 2. So subbing D over 2 into this formula, we get that F is equal to 200 divided by D over 2 all squared. So what we've done is replace the value of D in this formula for D over 2. And hopefully you can see how important the use of brackets are in this substitution. So let's now work out the value of F algebraically. So squaring the denominator, we get that F is equal to 200 divided by D squared over 4, which we could also write as follows, that F is equal to 200 divided by D squared over 4. By flipping this fraction and multiplying by 200, we would get that F is equal to 4 times by 200 over D squared. Now here I've intentionally not evaluated 4 times 200, because if you notice the difference between this formula and this formula, well, the only difference is that this formula is the same as this formula, but multiplied by 4, which happened as a result of us taking half of the distance, D over 2, which shows algebraically that when you divide D by 2, F becomes 4 times larger. Okay? Let's have a look at the last couple of questions. If R is inversely proportional to the root of P and R is equal to 2 when P is equal to 9, the first part asks us to find the formula for R in terms of P. The next part asks us to find the value of R given that P is equal to 36. And the last part asks us to find the value of P given that R is equal to 3 over 4. So you have all the tools. Why don't you pause the video to have a go at this question? When you come back, I will show you the work solutions. Welcome back, guys. So since we're told that R is inversely proportional to the root of P, we can therefore say that R fish sine 1 over the square root of P, and therefore R is equal to K over the square root of P, where K is a constant to be found, and we can just label this equation 1. Now, using the fact that R is equal to 2 when P is equal to 9, we can sub these values in to equation 1 to work out the value of K, and therefore 2 is equal to K divided by the square root of 9. The square root of 9 is plus or minus 3, but as mentioned, when dealing with quantities in proportion, we always take the positive value. So therefore 2 is equal to K divided by 3. Multiplying both sides of the equation by 3 gives us that K is equal to 6, and so we can find a formula for R in terms of P by subbing K equal to 6 into equation 1 to get that r is equal to 6 over the square root of p. The next part asks us to find the value of r when p is 36. So subbing p is equal to 36 into this general formula, we get that r is equal to 6 over the square root of 36. The square root of 36 again is positive or minus 6, but we take the positive version to give us that r is equal to 6 over 6, which is equal to 1. Okay, and the last part asks us to find the value of p given that r is 3 over 4. So subbing this fraction into this formula, we get 3 over 4 is equal to 6 divided by the square root of p. The aim is to make p the subject of this equation, so I'm going to multiply both sides of this equation by the square root of p to get 3 over 4 times by the square root of p is equal to 6. We can get the p term on its own by multiplying both sides of this equation by 4 over 3 as follows. So therefore the square root of p is equal to 6 times 4 divided by 3. 6 times 4 is equal to 24. 24 divided by 3 is equal to 8. And therefore the square root of p is equal to 8. So to get the value of p, we need to square both sides to get that p is equal to 64. Okay, let's have a look at the last question of this tutorial, which was an exam question. So here we're told that y is inversely proportional to x cubed. Y is equal to 44 when x is equal to a. Show that y is equal to 5.5 when x is equal to 2a. So why don't you pause the video to have a go at this one, and when you're back, I'll show you the work solutions. Welcome back, guys. So as we're told that y is inversely proportional to x cubed, therefore we can write y fish sign 1 over x cubed, and therefore we can say that y is equal to k over x cubed, where k is a constant of proportionality, and we can call this equation 1. Now we're told that y is equal to 44 when x is equal to a, and we've been asked to show that y is equal to 5.5 when x is equal to 2a. So let's use the information we're given and substitute these terms into equation 1 to get the following, that 44 is equal to k divided by a cubed. And so by multiplying both sides of this equation by a cubed, we can find an expression for k, which is equal to 44a cubed. And as normal, we would substitute this expression for k back into equation 1 to get a general formula for y in terms of x to be 44a cubed divided by x cubed. So now we have a general formula for y in terms of x. We need to show that y is equal to 5.5 when we substitute x equal to 2a into this formula. So let's go ahead and do that. So subbing x equal to 2a into this formula, we get that y is equal to 44a cubed divided by 2a all cubed. Now again, when substituting algebraic terms into a formula, you need to be careful. This is not 2a cubed, but this is 2a all cubed. All right, so expanding the denominator, we get the y is equal to 44a cubed divided by 8a cubed. 2 cubed is 8 and a cubed is a cubed. And now we should notice that we have some terms that cancel. We can divide the numbers 44 and 8 by each other to get 5.5. And we should also notice that we're going to get cancelling of the a cubed terms, giving us that y is equal to 5.5 as required. Okay, so thanks for watching this tutorial. Keep up the good work and I'll see you soon. If you like this video, please give us a thumbs up, leave your comments down below, and subscribe to this channel so you'll be the first to know when we release our next videos.